Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on September 10th, 2025, just 2 days ago. The standout finding is stark. Incorrect conclusions based on LLM annotated data occur in approximately 1 in 3 hypotheses for state-of-the-art models, and in half the hypotheses for small language models. The paper is titled, Large Language Model Hacking: Quantifying the Hidden Risks of Using LLMs for Text Annotation. And as we will see later, the implications for scientific inference are quite serious. The study audits 37 annotation tasks with 13 million labels and shows that type 2 errors dominate, while effect sizes often get distorted. On X, reactions stress that automated annotation lets researchers manufacture desired results, with incorrect findings in roughly 1/3 of cases, and they urge rigorous verification and human oversight. One post shows strong engagement. Alright, the previous segment highlighted widespread incorrect conclusions and strong reactions online. Figure 1 lays out the pipeline, end to end, which matters because each step introduces choices that can flip results. The left panels list 37 tasks and 2,361 hypotheses. The center panels note 18 models producing 13 million annotations and 1.4 million regressions, and the right panel shows conflicting p-values across configurations. The purple box crystallizes the risk. LLM hacking sits around 31 to 50%. Annotations trigger text. Figure 1 lays out bounding box 0.02, 0.02, 0.98, 0.78, trigger text. The left panels list bounding box 0.03, 0.07, 0.07, 0.56, 0.62, trigger text. The center panels note bounding box 0.75, 0.75, 0.75, 0.72, 0.72, 0.96, 0.96, 0. So the previous figure summarized the end-to-end pipeline. Table 1 catalogs the 37 annotation tasks, which span essays, manifestos, tweets, news, hate speech, and more, along with ground truth classes and prompt counts. The table also lists how many prompts were zero-shot or paraphrased, which matters because prompt variety changes label distributions. The final row aggregates scope. 21 datasets, 145,000 used data points out of 1.53 million, 199 prompts, and 2,361 groupings for hypothesis tests. Alright, the previous table cataloged tasks and prompt variety. Figure 2 shows 2 scaling curves that link model size to both risk and accuracy. The left panel reports LLM hacking risk dropping as parameter count grows, which flattens for models above roughly 30 to 70 billion, so returns diminish. The right panel shows weighted F1 rising with scale, yet risk remains non-trivial even when accuracy is high. The combined message is that bigger models help, but they do not remove inference risk. So the previous figure showed diminishing returns from scale. Table 3 summarizes model-by-model risk, which directly compares LLM hacking risk and the 4 error types. The best overall risk lands near 0.312 for GPT-4o, while small models like Llama 3.21b reach about 0.503. Type 2 errors dominate across families, with many entries around 0.33 to 0.59, so missed true effects are the main failure. Type M risk remains sizable, which means detected effects often have distorted magnitudes. So the previous table compared risk by model. Figure 11 shows how LLM hacking risk changes with more human ground truth samples and with different mitigation strategies. The gray circles drop steadily, which means using only human annotations cuts risk the most, reaching about 20% at 1,000 samples. The yellow and green lines improve with more ground truth, yet they stay above the gray curve because estimator corrections trade lower type 1 errors for higher type 2 risk. The red averages remain highest, so relying on unselected models is least safe. Okay, 2 takeaways stand out. Automated annotation is fragile, with 1 in 3 conclusions flipping even for top models, and the biggest driver of error is proximity to the significance threshold, not clever prompting. The broader implication is simple. Treat LLMs as fallible instruments and put humans back in the loop to anchor inference. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.